Hi, so my name is Shami. So basically, why we use Thevenin theorem is Thevenin theorem is an easy method for analyzing power circuits, which typically has a load that change value during the analysis process. Theorem ni provide an efficient way to calculate the voltage and current flowing across a load without having to recalculate your entire circuit. So which is Thevenin theorem ni menyenangkan kita. So maximum power transfer theorem states that to obtain maximum external power from a source with internal resistance, the resistance of the load must equal the resistance of the source as viewed from the output. So maknanya power yang dipindahkan daripada RTH kepada RL ni adalah mestilah sama, which is RTH ni adalah resistance supply. So basically lepas pemindahan tu kedua-dua nilai resistance ni mestilah.
Question related to Thevenin theorem. So this question is basically asks us to find the Thevenin equivalent circuit of the circuit shown in figure 5.16 to the left of the terminals A to B. Then find the current through RL 6, 16 and 36 ohm. So these are the figure 5.16. First of all, we need to find RTH by turning off the 32 volt voltage source, replacing it with the short circuit, and 2 ampere current source, replacing it with an open circuit. So once we replace the RTH, the voltage source and the current source, we get the circuit like this. So then we need to find RTH. So these are the calculation for finding RTH, and we need to find VTH. VTH by applying the mesh analysis to the two loops. So these are the loop 1 and loop 2. So once we can find the VTH, here the calculations and the value for the VTH. So this is the Thevenin equivalent circuit. Once we find the VTH and RTH, we can get the Thevenin equivalent circuit. So this figure shows the Thevenin equivalent circuit. So for finding load current, we can use the formula VTH over RTH plus RL. So when the RL equals to 6 ohm, the current we obtain from calculation is 3 ampere. Same for the measurement. These are the circuit constructed in multi-sim, where the V1 will be the voltage source through 30 volt, and the R1 is the resistance value, and the R2 is the RL. RL we said here is 6 ohm. Then for calculating the current, for measuring the current, we use the multimeter to measure the current. So the current we obtain for 6 ohm is 3 ampere. And then for calculations is for RL, when RL is 16 ohm, the IL, the current load we get is 1.5 ampere for calculation. Same for the measurement, we get 1.5 ampere. And then for RL, when RL equals to 36 ohm, the current load we get is 0.75 ampere. So the measurement we can get is 750 milliampere. So thank you.
Hi, my name is Muhammad Adik Najmi bin Zamri. Today I'm going to explain how to find maximum power. Okay, so this is the question. Use the Thevenin theorem to find maximum power. This is the circuit. Then to find the maximum power, first we need to find the RTH. To find the RTH, we need to take out the RL resistor and then 5 ampere. Then we just calculate all these resistor right here. Then we obtain RTH equal to 15 ohm. The second step is to find the VTH. To find the VTH, we need to use nodal analysis and Kirchhoff current law. So we just label here A, B, C, D and E. Then we put back the 5 ampere at C right here. So using Kirchhoff current law equation, we obtain 5 ampere equal to I1 plus I2. For I1 is at 6 ohm, so VD minus 24 volt divided by 6. For I2 is at 12 ohm right here, then VD minus 0 divided by 12. The current is toward the ground, so we need to minus VD with 0 equal to 5. Then we just solve the equation and we obtain VD equal to 36 volt. To find the VTH equal to VC equal to VD plus IR. So just substitute the value, then we obtain VTH equal to 56 volt. The final step is to find maximum power. So to find the maximum power, we use this equation P max equal to 1.4 VTH square per RTH. Just substitute all the value, then we obtain 52.27 watt. Then draw the Thevenin equivalent circuit. After that, we need to simulate it at multisim. Then just draw the Thevenin equivalent circuit like this. Then we obtain the RL is 15 ohm. Thank you.